Now let's do example 4. An object is released from rest. Apart from being acted upon by gravitational pull, G, the resistance of the object encountered varies with its velocity, thus giving its acceleration as g minus kv, where k is a positive constant. So given that dv dt equals to g minus kv, show that v equals to g over k, 1 minus e to the power of negative kt, where t represents the time when the velocity of the object is v. So we are going to start from its model. So we have dv over dt equals to g minus kv. And then let's separate the variable. So dv will be gathered with g minus kv. And we have dt on the other side of equation. And then of course we have to integrate both sides. So integrate our left hand side. We are going to get ln g minus kv, but don't forget to differentiate our g minus kv with respect to v, so we have negative 1 over k. And then you integrate dt, the answer will be t plus with c. So from the question, we know that the object is released from rest. So this means when t equals to 0, v equals to 0. So let's substitute into our general solution. When t equals to 0, so v equals to 0. So we have here negative 1 over k, and then ln g equals to c. So this is the value of our c. So now we have to substitute our value of c here. So now the equation becomes negative 1 over k ln g minus kv is equals to t minus 1 over k ln g, which is our value of c. And then now I'm going to collect together a term with ln. So we have negative 1 over k ln g minus kv plus with 1 over k ln g is equals to t. And then we can factorize negative 1 over k. So now we have ln g minus kv and minus with ln g, so equals to t. Now we can factorize 1 over k. So when we factorize 1 over k, we have ln g minus with ln g minus kv equals to t. So using laws of logarithm, now we have ln g divided by g minus kv equals to t. So we can do cross multiplication. So we have ln g over g minus kv is equals to kt, and convert from ln to exponent. We have g over g minus kv equals to e to the power of kt. So to prove, so we have to make v a subject. Now we have to cross multiply first. So we have g equals to g e kt minus with e kt kv. What I'm doing is I cross multiply here, and then we can bring terms with v on the other side. So we have e kt times with kv equals to g e kt minus with g. And then our v is g e kt minus with g divided by e kt multiply with k. So we just want v on the left hand side here, So we bring others to the left hand side and factorize g. So now we have v equals to g. So we have ekt minus with 1 over with k ekt. And then to prove what we want from the question, now we have g over k, and then ekt divided by ekt is 1, minus 1 over ekt is e to the power of negative kt. So proof.